So now what we're going to do is we're going to take a more likely what you'll see on your test is something that says, all right, our problem wants you to calculate what heat it would take to go from negative 18 degrees Celsius, solid water, or ice, whatever you want to call it, all the way up to, um, let's say, vapor at 112 degrees Celsius.
Okay.
So do you see how it's a little bit more complex now?
Yeah, because you have like a gajillion steps in
A
between.
gajillion, but how many of those steps have you done already?
I mean, I did them,
Oh.
but like,
I gave you the same temperatures and it's the same amount, 52 grams. So we've already done a lot of this problem.
okay.
All right? Do you understand what I'm saying?
Yeah.
Because we just calculated from negative 18 to 0. That was the 3900. We've done the portion that was vaporization, which is this portion right here. All right? So we've taken care
Mhm.
of these two. So what's left? Well, what's left is the fusion portion.
Mhm.
So we got to do fusion, and then we got to do this portion,
Plan.
and then that little portion in yellow is left. Okay, so you're right. If we were given this from the beginning, it would be 5 different calculations, but we've done 2 of them, so it should be a lot quicker than you anticipate. So let's do the easy one first. Let's do the one that's the fusion. If you remember, the constant for fusion was 46.7, I believe, kilojoules per
No,
mole.
no, no. It's 6 point. No, is it
Yeah, no,
fusion?
you're right. You're right. You're right. It's
Point
6.01.
01.
I gave you the one for sublimation. Sorry. So at this point,
What the moles are, so we just multiply that times the moles.
mhm. So how many moles do you remember?
It was 2.886.
Good. So 6.01 kilojoules per mole times the
Mm-hmm.
2.886 from earlier that we calculated here,
Mm-hmm.
moles, gives you
17.34.
okay. And this had again 2 sig figs, I believe, right? So let's just say 17 kilojoules.
What do you have
So
to do in the end? Do you just add up all that you found or something? Or
that's exactly right. Good girl. So fusion,
wow.
we've taken care of that. Let's do the first slanted portion. So what is the melting point for water?
Uh,
What is this
100
temperature? And what
or
is the
100?
no? That's the boiling point. That's the one up here.
Oh,
What is melting?
30 something? I have no idea.
Zero
Like
degrees
zero?
Celsius. Yes.
I thought that was freezing point.
Well, if we're going from liquid to solid, it's called freezing. But when we're going from solid to liquid, it's melting point, or the process is
Oh.
referred to as fusion. Okay? So Q of, I'll call this region 1, and we can do this as region 2. So Q of 1 would be MSAT. This one was delta H of fusion times N is the formula we use up here. Here we have MSAT. So the mass was 52 grams. The specific heat, again, is 4.18. And the change in temperature is what?
it's not, is it 0 to 18 or is it
We're in region 1 over here. So we start at 0 and we're going up as we go to the right, so it'd be to 100. So
100 minus 0?
Yeah.
Okay. Right, I got 21,736.
Okay, and how many sig figs given?
We have technically 1 sig,
Mm,
100, right?
oh yeah, for the temperature. Okay. So it would be what?
2,000. I mean, sorry,
Mm.
20,000.
20,000. Good, because it was 21,736. 1 sig fig is right here, so this tells us to round down. So 20,000. Can I put 20 kilojoules? Is that okay with you?